Hai, Assalamualaikum warahmatullahi wabarakatuh. Good day to Dr. Ahmad Kasruddin. My name is Muhammad Hadi bin Zulikam. My ID number is EA18167. So for this assignment 2, it's about research and proposal, which we are going to talk about AGV. AGV is the main title about automated guided vehicle. But what we are going to talk about is how this AGV system gives efficiency and autonomy for interest inventory management system. So for the next presentation, I will pass to my friends first, then I will go back to my part that, that I'm going to present. So I'm going to pass to Shamil, which he is going to present about summary of this research.
Assalamualaikum, my name is Muhammad Syamil bin Agama. Now I want to share you all about the executive summary. Okay, there is a point can be discussed by my friends. Okay, for the executive summary, I can elaborate about the background of research is to conduct researching about design and automated guided vehicle. In solving inventory management problem and applied research type is used for the investigation. The function of a GV is a load carriers that travel along the flow of a facility without an onboard operator or driver and give more benefit in delivery efficient, cost-efficient movement of material. Based on problem settlement and objective achieved from this research, the methodology is founded and proved by using block diagram in figure 1 and flowchart in figure 2. Besides, this topic highlighted the budget for supply material and installation costing based on affordable value and compliance of quality assurance. Expected outcome referred in Gantt chart. The conclusion for this chapter, the knowledge about engineering technology of AGV will be expanded from the exposure of research. Okay, that's all for my point. Okay, we can continue for the next slide. Thank you.
Assalamualaikum and hi, my name is Siti Nofaralin binti Ismail. ID number TG18025, section 3P. Today I will present about research background. Research background: computer control and wheel-based automatic guided vehicles (AGV) are load carriers that travel along the floor of a facility without an onboard operator or driver. Their movement is directed by a combination of software and sensor-based guided system. Typically, battery-powered AGV system consists of multiple vehicles that navigate along predefined guide paths. Vehicles navigate in the facility using several guidance technology include floor surface mounted magnetic tape or bars, lasers, optical sensor, and magnet or gyroscope based inertial guidance. For real-time control and monitoring of multiple AGVs, computer-based software uses wireless connections to collect data about each unit's current location. Then, interface for software for destination and routing logic, feasible to provide different routes and junctions that can be selected by the overall control system to allow the AGV to deliver products via different routes to multiple operations. The AGV often operate in the same working area as other users, such as forklift trucks and the workforce. Therefore, they include appropriate safety system. There are several types of AGVs: automated charts, unit load AGVs, tugger AGVs, automated forklift AGVs. Characteristic of AGVs excel in application. Repetitive movement of material over a distance, regular delivery of stable loads, medium throughput or volume, when on-time delivery is critical and late deliveries are using inefficiency, operation with at least two shift processes where tracking material is important. AGV provide automated material movement for a variety of industry including efficient, cost-effective movement of material is an important and common element in improving operation in many manufacturing plants and warehouses.
So back with me again. So the problem statement for this research is we have four main problems in every AGV system. First, the design of the guide path, which means this problem specifies on possible path on which a vehicle can travel. The second one, we have a dispatching problem. This specific problem, which is about where and when vehicles should go for the container loading or discharging task. And for the third problem is a vehicle routing, which aim at finding good path for the vehicle, for the AGV vehicle, dispatch for a certain task. And lastly is a conflict resolution. It is mainly for fleet of vehicle between the vehicle and other container handling the equipment. So basically, these four problems are need to be solved before we proceed with the research. Thank you.
Assalamualaikum and good morning. I am Ahmad Atiq Fikir Ahmad Razman, EA 18161. Today I will present about the objective of our research. The objective of this research is divided into 3 points. First point is to find out the efficiency and effectiveness of automated guide vehicle AGV system in industry for the specific task by using EEG signal. Second point is to extract the most suitable features such as cost, design, durability and flexibility of AGV system and EEG signal classification for modern industry. And the last point is to provide the last objective is to provide creative solution that enable individual with motor, sensor, uh, co- cognitive disability to be more independent, productive, and include in society and community life.
Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Nur Ismaili Sulaika binti Muhammadin, EC 18070, will be presenting the methodology of AGV. There are seven types of AGV navigation: wired, guide tape, laser target navigation, inertial navigation, natural feature, vision guidance, geo guidance, and lastly geo guidance. So let me walk through you each of these types. First is the wired. A slot is cut in the floor, and a wire is placed approximately 1 centimeter above surface. The wire is used to transmit radio signal. Sensor from bottom of AGV will detect the signal and it will regulate the navigation. For guided tape, the AGV is fitted with the appropriate guide sensor to follow the path of the tape. One major advantage of tape over wired guidance is that it can be easily removed and relocated if the course needed to change. Colored tape is less expensive, but lack advantage of being embedded in high traffic areas where the tape may become damaged or dirty. A flexible magnetic bar can also be embedded in the floor like wire, but work under the same provision as magnetic tape, so remains unpowered or passive. Laser target navigation. is done by mounting reflective tape on walls, poles, or fixed machines. The AGV carries a large transmitter and receiver on a rotating turret which is received by the same sensor. The angle and sometimes distance to any reflector that in line of sight and image are automatically calculated. This allowed the navigation system to triangulate the current position of the AGV. The current position is compared to the path program into the reflector layer map. The steering is adjusted accordingly to keep the AGV on track. Currently, there are two laser target navigations. First is the modulated laser and the pulse laser. First, the modulated laser. By emitting a continuous fan of modulated laser light, a system can obtain an uninterrupted reflection as soon as the scanner achieves line of sight with a reflector. The reflection ceases at the trailing edge of the reflector, which ensures an accurate and consistent measurement from every reflector on every scan. By using a modulated laser, a system can achieve an angular resolution of, I would say, 0.1 amberad or 0.06 degree at 8 scanner revolution per second. For pulse laser, a typical pulse laser scanner emits pulse laser light at a range of 14,400 Hz, which gives a maximum possible resolution of 3.5 mRad (0.2 degree) at 8 scanner revolution per second. To achieve a workable navigation, the reading must be interpolated based on the intensity of the reflected laser light to identify the center of the reflector. For the initial navigation, with inertial guidance, a computer control system directs and assigns tasks to the vehicle. Transponders are embedded in the floor of the workplace. The AGV uses the transponder to verify that the vehicle is on course. A gyroscope is able to detect the slightest change in the direction of the vehicle and corrects it in order to keep the AGV on its path. The margin of error for the initial method is plus minus 1 inch. Natural feature navigation. One method uses one or more range-finding sensors, such as laser rangefinder, as well as gyroscopes or initial measurement units with Monte Carlo/Marco localization technique to understand where it is, as it dynamically plans the shortest permitted path to its goal. The advantage of this system is that highly flexible for on-demand delivery to any location. They can handle failure without bringing down the entire manufacturing operation. Since AGV can plan paths around the failed device, they are also quick to install, with less downtime for the factory. Vision guidance. They operate by using cameras to record features along the route, allowing the AGV to replay the route by using the recorded features to navigate. Vision-guided AGV uses evident technology and application of probabilistic volumetric sensing. The evidence grid technology uses probability of occupancy for each point in space to compensate for the uncertainty in the performance of sensor and environment. These sensors are specially designed stereo cameras. The vision-guided AGV uses 360-degree images and builds a 3D map, which allows the vision-guided AGVs to follow a train route without human assistance or the addition of special features, landmarks, or position systems. Geoguidance. A geoguided AGV recognizes its environment to establish its location. Without any infrastructure, the forklift acquired with geoguidance technology detects and identifies column slats and walls within the warehouse. Using this reference, it can position itself in real time and determine its routes. There are no limitations on distance to cover number of pickup or drop-off locations. Routes are infinitely modifiable. That's all for me. Thank you.
Assalamualaikum and hi. My name is Muhammad Nazmi bin Muhammad Rosli. My ID number is EA18191. Today, I want to continue my friend's presentation, which is on financial budget for an AGV. First of all, let's talk about the price. As we all know, the AGV cost is different depending on the AGV type itself. For an example, it can be starting from 14 for an automated guided cart AGC, near 30 for a towing tractor, 60 for an automated pallet jack, around 80 for a forklift AGV, and around 150 for an automated very narrow aisle truck VNA. The figure 1 below shows an example of AGV, which is commonly used in the factory. As you can see, there is no need a human or a driver to drive the vehicle, as it can drive by itself, which has been programmed by the programmer to conduct a specific jobs. Next is how much does an automated guided vehicle cost? The following table indicates automated guided vehicle cost depending on AGC type and navigation technology. There are 4 types of AGV. The first one is AGC, which is automated guided cart, unidirectional towing. For 1 ton, the magnetic or optic each AGV is 14. And for free or laser navigation on each AGV, it will cost around 25. The next is bidirectional towing. It will cost magnetic or optic each AGV for 23 and free or laser navigation for 30. The third one is rotating towing. It will cost around 18 for a magnetic and 27 for laser navigation. For AGC omnidirectional lifting, the price for the magnetic or optic is not been stated, while the price for the laser will cost you around 35. An automatic guided cart is the simplest kind of an AGV. There are several types of several cart and with different navigation systems too. AGV can cost more power, more battery, and more structure, and thus it will cost you more. The amount of the project budget will also influence the planning. In the final account, the budget is also a key factor in determining a complexity of the project.
Assalamualaikum. My name is Aliza Azmi. My ID is EA18020. I'm going to talk about expected outcomes of AGV system. AGV systems are now primarily used for intelligent transportations and distributions of products in warehouses and facilities. With AGV system, the facilities are now changing into fully automatic facilities. AGVs improve the efficiency of facilities. AGV systems also helps the usage of forklift and transport trucks to be reduced, which decreasing the labor costs. Most importantly, the systems help to boost up the facilities' performance. AGV systems are efficient, flexible, and reliable for our systems, and also has a high level of safety comprehensive technology, security technology, which makes the vehicles that use the system are more robust with high performance. That's all from me. Thank you.
Name is Siti Nuraini binti Cik Uhaimi. My ID number is EA18120. Today I will show you about the Gantt chart. This Gantt chart gives you a clear illustration of the resource proposal status. Gantt chart of research is used bi-monthly and its duration is 2 years. For the first task, it is introduction to the research topic. It takes 2 months. For review of literature, it takes 4 months. For research methodology, it takes 4 months. For research proposal writing, it takes 2 months. For data acquisition, it takes 2 months. For processing and feature extraction, it takes 4 months. For machine learning, it takes 4 months. For system integration and prototype development, it takes 2 months. For project experiment, we take 4 months. For the last final proposal writing and submission, we take 6 months, which is in 19, 20, 21st, 22nd, 23rd, and 24th months for the whole proposal. Thank you.